Okay, so we're starting 2.6, which is inequalities. Okay, let's share the desktop. Okay, so what is the difference between less than and less than or equal to? So my question is, and what is the difference between these and equal sign? Now let's look at the number line. Okay, so when I say x is equal to 3, so how many points are solution? How many solutions do I have when I say x is equal to 3? How many solutions? 1, 2. How do we get 2, by the way? Only 1, right? So this is only one solution, which is 3. Now, if I say x is less than 3, how many solutions? How many solutions do I have? So what numbers are less than 3? Can you mention some numbers that are less than 3? 2. Okay, what else? 1. What else? What is it? -3. How about -3.0001? Yes. So how many solutions do we have? We have infinitely many solutions, not just one point. Yeah, not just one solution, but we have infinitely many solutions. Okay, so that's why when we have inequality, we can't just answer x is less than 3. The solution is x such that x is less than 3. So this is vertical bar right here is read as such that. So x such that x is less than 3. Now usually we could add this also, comma, x is all real number. So let me see what this is. This e, this is called epsilon, but this just means is an element of. Yeah. So this e, this is a Greek letter e, like epsilon. So it's like C. It's not like E like this, but it's more like a C. It's more like a C, and then with a stripe in the middle, with a line in the middle. Yeah. So it's read as is an element of. Okay. And then this R with double bar. So this is real number, the set of all real numbers. So the set of all real numbers. Okay. And this is called set builder notation. Okay. All right. Now, so how am I going to graph x is less than 3? So this is 3 here. And it will have an open circle. Why open? Well, because the solution doesn't include 3. So it looks like this. Yeah, that's the graph. Or in Math Excel, it uses parentheses. So this is equivalent to this. In Math Excel. I don't like the second one, so I don't use it too often because they overlap. You can't really see the answer. Yeah, I like to use the first one instead of the second one. But I guess Math Excel and some other books uses the second one. Yeah, but for class purpose, we will use the first one. Okay. All right. Now let's go back to my question. Yeah. What is the difference between x is less than 3? All right. So next page. So what I want to know is what is the difference between So what is the difference between x is less than 3 and x is less than or equal to 3? Is that a difference? Do you think they're different? They are or aren't they? They are, yes. What is the difference? One is equal to 3, the other one does not include 3. So, can I say 3 less than 3? Is this a true statement? No, this is false. Right? Okay. So, what about, can I say 3 is less than or equal to 3? This is true? Yes. So, how would you answer it? Actually, Javier, you already answered. Javier already answered. So, x less than 3 does not include 3. Okay? And x less than or equal to 3 includes 3 on the solution set. Yeah? Okay. So how do I graph x is less than 3? X is less than 3, the graph looks like this. So 0 is in the middle, 3. I will have an open circle, and the arrow will point to the less than, so it's pointing to the left. Yes. So this is when it's not included. So we have an open circle. So this is called a hole or open circle or a hole. Now what happens if it is included? It's going to be a closed circle, meaning 3 is included. So this is a closed circle. Closed circle. Okay. And why does my arrow point to the left for both? How come it doesn't point to the right? It's less than. So the values that are less than 3 are to the left of 3. Yeah, that's why. What about if the inequality contains greater than? So x is greater than 5. It points to the right. Good. Easy? Okay. So now let's talk about interval notation. So we talk about set builder notation. So let's talk about interval notation. So interval notation. All right. So before we talk about set builder notation, which is almost the same as the inequality itself. So what's the rule for interval notation? Oh, what is this? Okay. So what's the rule for interval notation? So one, it starts from left to right. So from the smallest to the largest solution. So it's the smallest to the largest. Yeah. 2, we use parentheses for less than or greater than. So if it's not included, we will use parentheses. So use parentheses for greater than or less than, or for negative infinity and infinity. Maybe I should say this. Negative infinity to or infinity. And we use brackets, so we use brackets for less than or equal to or greater than or equal to. Yeah. All right. So that is interval notation. Now, on the next page, we will talk about doing a summary. Okay. So the next page. So which one? Where do we use bracket? Well, when we have less than or equal to. So how do I write the interval notation for the first one? Let's write an interval notation for this. What's the smallest solution? What's the leftmost? Negative infinity, right? What is the smallest solution on the left? We don't know. We use negative infinity, comma, 3. So this is the interval notation. Now, for negative infinity, what do I use? Parentheses. For 3, what do I use in this case? Parentheses or bracket? No, this is parentheses because this is not included. Yeah. So for open circle, you use parentheses. Open circle. So anything open circle, negative infinity or infinity, we use parentheses. Okay. And anything with closed circles, we use brackets. All right. So bracket is for closed circle. Parentheses is for open circle. Now, what about the second one? Oops. What is the smallest solution here? Negative infinity, and for negative infinity, we always use parentheses. Comma, 3, and what do I use here? Brackets. Yeah. Okay. So today I just gave my Math 260 students a quiz, and then some of them didn't know how to use the bracket or the parentheses. Okay. But anyhow, you now know. When do we use parentheses? Open circle. When do we use bracket? Closed circle. Yeah. Okay, good. Now, the next one, let's do a few interval notation. Okay. So let's write down the inequalities. So these are all simple inequalities. And then graph. The AC is still not working, right? Graph. And then set builder notation. And interval notation. All right. Okay, so the inequality is x is less than negative 2. Number 2, x is greater than 3. Number 3, x is less than or equal to 4. Number 4, x is greater than or equal to negative 6. And number 5, x is in between negative 3 and 5. So what we're going to do is write the graph, write down the set builder, and then interval notation. Okay. All right. So let's graph. How do we graph the first one? Well, let's see. Is negative 2 to the left of 0 or to the right of 0? Left. So right here. Open, close. Open. What about my arrow? The arrow points to the left. Yeah, like this. Okay. So set builder notation, we're just using the set, the curly bracket, x such that x is less than -2. So I could stop here and put another set, or I could put x is an element of real number. Yeah. So it just says that x is less than -2 and x is an element of real number. Do you want me to close the door? It's really hot. Yeah. Okay. Now, how do I write my interval notation? So from left to right. So what is my smallest solution here? What is the smallest solution that I have here? -infinity. Okay. And I have to use parentheses, comma, -2. And do I use parentheses or bracket? Parentheses? Okay, good. All right. Now, number 2. So how do we graph it? 3. 3 open or close? Open, 3. And the arrow will point to the right. Why is it to the right? It's greater than. Not because it's positive, but because it's greater than. Yeah, so the greater than or the less than will determine where the arrow points. So write down the set builder. X such that what? X is greater than 3, and you could actually stop here. The x is an element of real number. This is optional. Yeah, but we assume that we know x is an element of real number. So you could stop here actually. So either way would do. So you could stop there, or you could write the whole thing. X is an element of real number. Both are acceptable. Yeah. Now interval notation. What's your smallest solution here? Well, -infinity is not part of your solution, right? So what is the smallest solution? What is the smallest solution? When you say x is greater than 3, what is the smallest solution? 3, but does it include the 3? No, so we will use parentheses. 3 to infinity. Does that make sense? Okay. So now, can you guys try number 3, 4, and 5, please? Okay. Let's see. So Daisy is here? Yes. James? Jennifer arrived? Andrea here? Zach? Absent? Guadalupe is here? Rainier late? Manuela? Okay. Nicholas here, Martin's here, AJ's here, Celine's here. Dominic. Maribel, late, right? Sylvester here. Sylvester, did I ever give you Atlas? Oh yeah, okay. Henry's here. Cecilia, Esmeralda, Jasmine Lopez. Okay. Noemi's here, Estefani's here. Jennifer Munoz, you're late, right? Really, Ornella's here. Georgia is here. Julio is here. Cesar is here. Melvin, did I ever give you Atlas? Did you catch up yet with the homework? 2 questions or 2 sections? Oh, then you're not caught up, right? Okay, so this week is the last time to catch up. Yeah, so by Thursday you should catch up. Destiny, absent. Jennifer Reyes. Millions here. Emma's here. Are you done? Clarissa is here. Oh, now it's open. Turn on. Lily is here. Renee is absent. Jamie absent. Javier's here. Did I ever give you Eclipse?
Yeah.
Oh, I did. Myra's here. Adriana. Is Adriana here? Yeah. Okay. Renee Sapala is here. Okay, good. Alright, so now, let's see. X is less than or equal to 4. So what do we do here? 4, open or close? Close. And the arrow will point to the left. Why to the left? It's less than. Good. So now the set builder is just X such that X is less than or equal to 4. So I could stop these. This X is element of real number is optional. So I could actually stop like right there. So as you could see, the set builder is almost the same as your inequalities, right? Okay. It just has X such that X is less than or equal to 4. Now, interval notation, what's the smallest solution? Leftmost solution. What is the smallest or leftmost solution here? Which one's the leftmost? The solutions are all these points, right? It says you set the arrow points to the left, so the solution is all these. So the solution is all these here. The solution is all these here. The solution is all these here. Yeah. So in this case, what is my smallest solution? What is it? Negative infinity. And for negative infinity, I always use parentheses. Comma. The largest solution is 4. And do I use bracket or parentheses? Yes. This is where we use bracket. Now, it doesn't matter. One side uses parentheses, the other side uses brackets. Yeah. So left side and right side are independent. So one can be parentheses, the other one can be bracket. Okay. Now X is greater than or equal to negative 6. So open or close at negative 6. Close. The arrow will point to the right. Okay. Why? Because this is greater than or equal to. So the set builder is X such that X is greater than or equal to negative 6. Can I write like this? X is an element of real number? Yes, it's optional. So you can write it or you don't have to write it. So it can be like number 3 because we already assume that X is a real number. Okay. Now the next one, what about the next one? What happened here? Interval notation. What is my smallest solution? Negative 6. Do I use parentheses or bracket? Bracket. Negative 6, comma, infinity, parentheses. Yes. Okay. Now, last one, number 5. What do we do? Well, it just says X is in between negative 3 and 5. So for negative 3, is it open or closed? Open. And for 5, it is closed. And it's just this solution. Yeah. How do I write my set builder? Exactly like your inequality. X such that X is in between, or you could say negative 3 is less than X, less than or equal to 5. Now, how do I write my interval notation? How do I write my interval notation? What's the smallest solution? -3, and I use parentheses. And what's the largest solution? 5, and we use, okay, good. So will you remember this? Yeah, my Math 260 student, pre-calculus student couldn't remember. Yeah, but this is important. We use it all the time. If you see here, the set builder is the same as the inequality, so it is always less useful because it's the same as the inequality. Yeah, I'm just using this yellow highlight to make sure that you understand. Actually, it doesn't need a highlight. Yeah. Okay, good. So we're ready with solving inequalities now? Yeah, are we ready? So C, solving inequalities. So C, solve, graph, and then write solution in set builder and interval notation. Interval notation. All right. Good. So, and we graph because inequality has infinitely many solutions. So let's do the example. Okay. So, for example, number 1. 5y plus 1 is greater than 16. And then number 2, negative 3x is less than negative 12. All right. So what would you do here? Yes. So we will have y on one side. Yeah. So what would you do? Subtract 1 from both sides. And remember, I'm going to copy my inequality. So 5y is greater than 15. So I cannot change my inequality to equal sign. Yeah, I'm copying my inequality. Okay. Then what would you do? Divide both sides by 5. So y is greater than 3. Yes. Now, how are we going to graph it? So let's graph it. Maybe let me just change this to, okay, so y is greater than 3. So 3, open or close? Open. And the arrow will point to the right, left? Right? Okay. Good. So what is my solution in set builder? Y such that y is greater than 3. And again, it's optional to write y is an element of real numbers. So this part right here is optional. Okay, so you could just say y is greater than y such that y is greater than 3, period. Yeah. How do I write my interval notation? So this is called set builder. How about my interval notation? What is it? 3, comma, infinity. And I'm using bracket or parentheses? Parentheses for both. Yeah. Okay, is it easy? All right. So 3 to infinity. Okay. Now number 2. And I have to put a note here. Negative 3x is less than or equal to, so I'm changing the problem a little bit. I'm including the equal sign here. Less than or equal to negative 12. So what would you do here? Divide both sides by negative 3. Now, one note, if we divide both sides by a negative number, we have to switch the sign. Yes. So do you remember that? So here, we switch the sign because we divide by a negative number. So very important is switch signs when dividing both sides by, or dividing or multiplying both sides by a negative number. Or dividing or multiplying both sides by a negative number. Okay, so x is greater than or equal to 4. Good. So now we're going to graph 4. Open or close? Close. And the arrow points to the right. Okay. Close. My interval notation? My set builder? X such that x is greater than or equal to 4. So I'm going to stop here. And my interval notation? 4 to infinity. So 4 bracket or parentheses here. Bracket? And infinity? Infinity what? Yes, infinity you don't have a choice. Yeah, parentheses. So very important is switch signs when dividing or multiplying both sides by a negative number. Yeah. So that's the only thing you have to remember. That's it. Yes. Hold on. Lily and Guadalupe, can you move here, please? Or can you move back over there? Please. All right. What was it, Javier? Oh, okay. So the question is, when do we know when is it parentheses or bracket again? So when we use close circle, it is included. So 4 is included. So that is when we use bracket. Yeah. Okay. Good. So far, so good. So let me give you a few numbers, and then you could try. Okay. Did I answer your question? Yes. Okay. So number 3. Is it easy actually? So no. Number 3. A over 2 plus 1 is less than or equal to 3 over 2. And then number 4. 2 is greater than 2 over 3 minus k over 3. All right. So number 5, let's see. We have, bless you, 4 minus 9k is less than negative 4k plus 19. Okay, so can we try these 3 problems? Alrighty. So try. So for number 3, what would you do first to get rid of the fraction? Multiply by 2. So multiply by 2 on the left and on the right. So multiply by each term by 2, by 2, by 2. Same with number 4, right? Okay, so I'm going to wait. You're going to have to try it. Let's see. So 5 minutes, then we will discuss it. Okay. Are you guys done? No? So shall we start? Yeah? Okay. So what do we do? Tell me. When's our test? Wednesday? Did I say Wednesday or Thursday? I said Thursday? Not Wednesday? Okay, so do you want to have it this Thursday? Or coming Monday? Monday, but I will start chapter 3. Yeah? Okay. So Monday we have a test, chapter 2. Yeah? Okay. Sure, yeah. So you prefer to study on the weekend? Oh, okay. Okay. All right. How many people came to the extra session here on Friday? Only 2, 3? How many? Only 3 people? Do you remember how many people showed up? Oh, 6, 7? Okay. Okay, good. Yes. Now, so this is 2 times, 2 times, 2 times, right? And when we multiply, remember we always multiply the numerator. So the 2 cancel, and these 2 cancel. So what am I left with? A plus 2 is less than or equal to 3. Okay, then subtract 2 both sides. So A is less than or equal to 1. Okay, good. So now it's easy. 1, open or close? Close. And the arrow points to the left. Yes. All right. So the arrow points to the left. Good. My set builder, A such that A is less than or equal to 1. And my interval notation, negative infinity, comma, 1 bracket. Yes. All right. Good. Doable? Okay. Now, number 4. Yeah. What did you say? Yes, it's always right to left to right. Whatever is on the left first. So you cannot say 1 to negative infinity. No, you cannot say that. Yeah. So this is not a correct interval notation. Yeah, it always goes from the left to right. Now, number 4. What do we do here? Multiply by 3. Okay, so 3, 3, 3. All right. So what is this? 6 is greater than the 3 cancel. 6 is greater than 2 minus k. Okay. Good. Now, what happens here? So subtract 2 both sides. Okay. So 4 is greater than negative k. Divide both sides by negative 1 or multiply by negative 1. It's the same thing. And what am I supposed to do here? Switch the sign. So negative 4 is less than k. Well, look at these. The k is on the right. So if negative 4 is less than k, can I say k is what? Greater than negative 4. Yeah. So I'm just using the concept that if negative 4 is less than k, it means k is greater than negative 4. Yeah, okay, so now let's graph this. So I want my variable on the left, actually. -4, open or close? Open. And the arrow points to the right. Okay. So, all right. And what was my interval as a set builder? K such that K is greater than -4. My interval? -4, and I use what for -4? Parentheses, -4 to infinity, and then parentheses. Yes, no? Yes. K such that? Usually we write it so that the K is on the left. Yeah. So usually we want to write it like this. Yeah. So even though it means the exact same thing, usually set builder, usually we write down K such that K instead of -4 is less than K. Yeah. So you might want to switch it so that the variable is on the left. Good. Any other questions? So the variable, it's better to have it on the left. Yeah. So using the concept, if -4 is less than K, what does it mean? Well, K is greater than -4. All right. Next, what are we going to do here? What are we going to do here? Subtract 4. Okay. So yes, we want the variable to be on the left. So -9K is less than -4K plus 19 minus 4, 15. Good. Then what? You add 4K to both sides. So what is this? -5K is less than 15. Good. And then divide both sides by -5. Remember to switch the sign. So right here, when I write division by -5, I switch the sign at that point. Yeah. So K is greater than -3. All right. So -3, open, close, open, and the arrow will point to the right. All right, what's my solution? K such that K is greater than -3. And what is my set builder? -3, comma, infinity. All right, doable? Okay, so a few more problems. So 6, 7, 8, yeah. Can I clarify anything before we move to the next page? Yes. Only if we divide or multiply by a negative number. So if I'm just dividing by 2, then we don't switch. So, and then here this is subtracting, right? Subtract by 2 both sides. So that's why we don't switch. This is subtracting. This is dividing. Yeah? So only when we divide or multiply by negative number. Yes. Good? All right, now, number 6. We have 6 times n plus 1 plus 2 times 4n minus 2 is greater than 3 times 5n minus 1. All right. And then number 7. -1/3 times 2y minus 5 plus 1/6 times 5y minus 2 is greater than or equal to 1. All right. And then, well, number 8, let me just write it here, but most likely I will have to copy it. 2.1x plus 3 times 1.4x minus 1.5 is greater than or equal to 0.09x plus 20.34. So 20.34. R. So would you try it? So 6, 7, and 8. All right. Are you done? Yeah? Are you done? Okay. So can you work on it? What was the answer for number 6? N is what? Less than or greater than or what? Less than what? Less than 5? Greater than 5? Or less than 5? Let's see. It's greater than, right? Why is it less than? Were you supposed to Change the sign? Yeah, I think so. You're supposed to switch the sign, right? Okay. Did you guys forget to switch the sign? How about number 7? Is it done? No? Okay. How about number 8? No? Should we just do it? Okay. So number 6. What should we do here? We distribute. So what do we have? 6n plus 6 plus 8n minus 4 is greater than 15n minus 3. Yes. Now combine like terms. 14n plus 2 is greater than 15n minus 3. Okay. Then subtract 2. Yes. Because we want n to be on the left. So we have 14n is greater than 15n. What is minus 3 minus 2? Yes. Good. And then what? You subtract 15n from both sides. So what is 14n minus 15n? Negative n is greater than negative 5. Good. So now what do we do? Yes, divide both sides by negative 1. Remember to switch the sign. So n is less than 5. Alright, now let's write down the step builder. So what is it? N such that n is less than 5. And the interval notation. Sorry, we haven't graphed, right? So it's easier if we graph. 5. Open or close? Open. And the arrow will point to the left. Yes. So this is n such that n is less than 5. Now, what is the interval notation? Negative infinity, comma, 5, parentheses or bracket here? Yes. Correct. So if you didn't do it correctly, it was just the sign here. Okay, so you have to remember. Yeah, because when we're dividing by 5, we need to remember. Good. Now, number 7, what should we do here? Multiply by the LCD, but just remember, you're going to multiply. This is one term. So this whole thing, if you're going to multiply by the LCD, you just have to remember that this is one term. This is another term. And this is another term. So will you remember that? Okay. So let's multiply by the LCD. What is the LCD? 6. So this 6 times 6. And here times 6. And here times 6. So each term we will multiply by 6. Good. Now what? Yes, so the 6 and the 3 cancels. What is 6 divided by 3? 2. Good. Now the 6 and the 6 cancel also, and this is 1 times 6. So what is this then? 2 times 2y minus 5 plus 1 times 5y minus 2. So you can write the 1 here, or you don't have to. Yeah, is greater than or equal to 6. All right. Okay, so what do we have now? 4y minus 10 plus 5y minus 2 is greater than or equal to 6. And then what? 4y plus 5y? Where? Oh, so this is supposed to be negative? Yeah, good. I didn't notice that, but yes, you're right. So I'm missing this negative. Is that right? Okay, so what am I supposed to have here? Negative 4y plus 10. Yes, good. All right. Thank you. So now let's combine like terms. What is negative 4y plus 5y? Y. 10 minus 2. So y plus 8 is greater than or equal to 6. Then what? Subtract 8 from both sides. Yes. So y is greater than or equal to negative 2. All right. So now let's graph these. Negative 2. Open or close? Close at negative 2. And the arrow points to the right. Okay. So y such that y is greater than negative 2. What about the interval notation? How do we write it? Negative 2, what type of bracket or parentheses? Bracket, comma, infinity. Yeah. Good. Yeah. Now in Math Excel, I think they do not have interval notation. Yeah. However, I'd like you to practice. So when you're doing homework for 2.6, which will be due on Wednesday, when on the portfolio, please write the interval notation. Yeah, just for practice, because Math Excel doesn't have it, and then if you don't practice, then you will forget. So have the interval notation on your portfolio. Yeah, just write the interval notation on your portfolio. All right, now the last problem. Let's distribute first. So 2.1x plus, what is this? 3 times 1.4. So 4.2x minus 4.5 is greater than or equal to 0.09x plus 20.34. Okay, so what should we do here? Oh, do you want to clear the decimal or no? No? Okay, so we can combine like terms. What is 2.1 plus 4.2? 6.3x minus 4.5 is greater than or equal to 0.09x plus 20.34. Okay, so what next? So you want to multiply everything now? You want to get rid of the decimal or just continue? It doesn't matter. So let's just continue. You could get rid of the decimal. Should we get rid of the decimal? Okay, how? Multiply by 100, both sides, right? Meaning each term. So I could write 100 times this, 100 times this, 100 times this, 100 times this. So either way. Now, when I multiply 6.3 by 100, what do I have? 630x minus 450 is greater than or equal to 9x plus 2034. Okay, good. So now put add 450 to both sides. So 630x is greater than or equal to 9x plus, what is this? 84? Yes. Good. Then subtract 9x from both sides. Do I switch the sign? No, I'm subtracting. So no. So this is 621x is greater than or equal to 2484. Then divide both sides by 621. Are we switching the sign? No, why not? Are we switching the sign here? No. Why? We are dividing by positive, not negative. So x is greater than or equal to 4. Alright, so now we have 4, open or close? Close, and then the arrow points to the right. And let's write the interval notation and the set builder. So x such that x is greater than or equal to 4. And then what's the other one? Negative infinity? Is that right? No. What is the smallest solution? 4. So bracket 4, comma, infinity. Yes. There you go. Okay. So is it doable? Okay. Remember the interval notation. When you're doing homework tonight, write the interval notation, okay? Even though Math Excel doesn't need it. Alright, so I'm done with 2.6. So tomorrow we will start 3.1. Okay? Okay guys, see you tomorrow. Good job today. I'm going to stop the recording. Alright, everybody finish? Okay. Yes.
I already did one, so I lost
Portfolio?
But I just go back on it.
You don't have to, but you're going to lose points if you don't turn in the portfolio. For the portfolio only, for the portfolio purpose.
Everything else is
Yeah, well, you probably have a 9 instead of a 10. But if you can go back and then write it if you want, but I mean, it's sort of a waste of time, right? So you probably don't need to do it. It's just 1 point or 2 points off on the portfolio, so it's really not that much. Okay? Yeah. Okay, so we're done with 2.6. So I'm going to stop recording.